So good evening everyone. So let's start our today's lesson. So our today's lesson is a simple topic which is motion in one dimension or kinematic, which is what we're calling kinematic. So kinematic, this deals with movement of object in x and y direction. But in today's lesson, we'll learn motion in one direction. That is our today's lesson. So I'll give an car or a bicycle. It moves in x-axis. This is a bicycle. Okay, I don't know how to draw, but I'll just like this. So this is a bicycle like this. So or the car moves it, or depends the road. So that is what we're calling motion in one dimension. It doesn't move to x-axis or y-axis only. It moves on to x-axis, yes, not in y. Even in y-axis can move, but in one dimension. That is what we are considering today. So if you are not careful, they ask questions which can be difficult for you, but as Strive Achievers will make it easy for you, because this topic is simple and easy. Yes. So what you need to know on motion one dimension, you need to know vectors. Yes, so vectors. So we have two quantities, vector quantity and this scalar. So scalar quantities. So that is our today's topic. So if they say vector quantities, these are quantities which has both what? Magnitude. So as both magnitude and direction, that is what we are calling vector quantities. So vector quantities, these are quantities which has both magnitude and what? And direction. So that is what we are calling a vector. What about the scalar? The scalar has only magnitude. That's all. Only magnitude, but vector quantity has magnitude and direction. You learned this. In grade 12, you learned this in motion. So this is simple and easy. So examples. So example, you can say distance, an example. Speed is an example for scalar quantities. Or vector quantities, displacement, yes, displacement, even the velocity, acceleration. Those are the key things which you need to know. Yes. So let's define each quantities. We need to know each quantity, what they mean. So each quantities. Okay, let's delete our board with white. Okay, let's delete our board now. So you need to know each quantities. Yes. So each quantity will give an, so we'll start with distance. So what is this distance? So distance, it is the path taken by an object. So this is an object, start from A, going to B, going to C. Now they say this is a person, he walks through, he went started from A. This is distance. I can say x final, x initial, he went back to what? To B. So there, that is bx initial, which is, oh, this is x initial, the distance at first, then the final is C to B. That is what the distance he moves. So if you want to calculate the distance, we just x final plus x initial. That is what we do to calculate the distance. So it is simple and easy. What another thing which we need to know? Displacement. So distance, first let's define the distance. It's just a path taken by an object. So path taken by an object, that is what we are calling distance. So that path which is taken by an object, that is what we are calling what? Distance. Yes. And also you need to know the other thing which we need to know, it is in a displacement. So what is displacement? So displacement, we go to displacement. So what is displacement? So displacement, it is the path taken by an object in a specific direction. So it is the path taken. So just as we said that the distance, it is the path taken by an object, that is distance. Now that is the same definition, but an object in a specific direction, that is only different. So it is the path taken by an object in a specific direction. So if the object takes the path taken by an object in a specific direction, because displacement, it is in a vector quantity which has both magnitude and direction. So there as in, yes, direction. Yes. And also what you need to know, let's give an example of a person. We use the same example, which is a person is moving. So there, which is x. No, I'll just give an example of this. So this is a person. So a person moves here, going to here. So as we know, the distance will add, if this is a distance x, we'll add also distance here. If this is distance a, this is distance b. So if we want to calculate the distance, we'll add this and that. That is what we will calculate the distance. But the displacement, we just go direct. We do not need to go this side, that is distance. Displacement is the path taken by an object in a specific direction. And that's why the displacement, it is x final minus x initial. That is in the formula for displacement. Yes. So let's go to speed. So speed is also simple. So speed, so what is the formula for speed? So speed is equal to distance over time. So even the definition, this is the change of distance over time. So the change of distance over time. So this is delta, which means the change of x, which is distance over time. So that is what we are calling speed. Yes, according over time. So distance over time, that is what the definition. So that is what we are calling speed. Distance over time. So the change of distance per time or over time, that is correct. Yes. And let's go to now velocity. So this is interlinked. So even velocity, we can say velocity, it is just to velocity, we can say the change of displacement. So the change of displacement per time, that is what we are calling velocity, because this is the vector quantity. Velocity is a vector quantity. Displacement over time or per time, that's all. Yes. When you go to acceleration, let's go to acceleration. So acceleration, what is acceleration? So acceleration, we write the formula for acceleration. So we know the formula for acceleration. It is acceleration is equal to v minus u over t. So here those are velocity final minus velocity initial. So acceleration, even the definition acceleration, this is a change of, this is velocity. So velocity, when it changes, it has the acceleration, the change of velocity per time. So this is the change of velocity with time. So here with time, yes, according, no need even to memorize. I don't like memorizing me. According to the formulas, then I develop the definitions. So it is as simple. Yes, another thing which you need to know, instantaneous velocity. So instantaneous velocity, this is a change of velocity at a specific time. So instantaneous, so instantaneous velocity. So instantaneous velocity, if this is velocity, this is time, or this is velocity. So velocity will change, will be changing here. The velocity will change at each specific time. The velocity will be changing. That is what we're calling instantaneous velocity. That's all. Yes, the last thing which you need to know are motions, or equations of the motion, equation of motions. So what is this equation of motions? So the first equation you need to know is v is equal to u plus at. We'll be using those equations as we start answering different questions. And another we need to know, it is v squared is equal to u squared plus 2as. Even you cannot even, no need to memorize those formulas. They can give you, or they give you in the paper. Yes, even distance is equal to 80 plus half 80 squared. So that's all. We end here for today's lesson. So you just need to know those. That is the introduction of kinematic, the introduction of motion one dimension. So we end here for today's lesson.